Hello friends, and welcome to the circle review. Okay, lots of things in circles actually need to be memorized. You need to know how to recognize and name a radius, diameter, and chord. It would be helpful to also be able to know how to name a tangent and know what one is. Remember, the vertex of a central angle touches the center of the circle, hence central, and is equal to the arc it makes. So the vertex of an inscribed angle does not touch the center of the circle. It's on the circle. So the angle itself, the vertex, is on the circle, and the ends of it are on the other side of the circle. It's half of the arc that it makes. Tangent lines are on the outside of a circle. They touch the circle at a single point and are perpendicular to a radius. Standard equation of a circle is x squared plus y squared equals r squared. In that case, it's centered at the origin. Arc length and arc measure are different. Arc length is measured in standard units of length, meters, centimeters, feet, inches, yada, yada, yada. But arc measure is given in degrees. Think of arc length like, you're measuring things with a ruler, only it's circular, versus arc measure, which is kind of more of a measure of rotation. If you rotate 90 degrees or rotate 30 degrees or 190 degrees. To find arc length, so that's the actual measure, how far is it from A to B along the curve, then you have to find a fraction of the circumference, a piece of the circumference. And remember that of means multiply. It's going to come in handy later. If a quadrilateral is inscribed in a circle, so inscribed means drawn inside. So if a quadrilateral is drawn inside a circle, then opposite angles are supplementary. So they add up to 180. And you may assume in this review that lines that appear to be diameters really are diameters, unless it tells you otherwise in the problem. Same is true with tangents. Okay, let's get started. Okay, remember to hit pause, name a radius, a diameter, a chord that's not a diameter, and a line that is tangent to the circle. Be very careful about your symbols, and I'll explain that in just a minute. Hit pause, I'll give you a couple of seconds, and then I'm going to keep going. All right, radius, you could say VR or RV, or AV or VA. Make sure that when you do so, you put a line like this, okay? This would not be correct because a radius does not go on forever. That would be a line. You also couldn't say V to R this way. That would be a ray, and it would say that the radius starts here and just kind of goes on forever that direction. A radius is actually a segment. It has a beginning and an end, and that's as long as it is. Same for AV or VA, yada yada. Okay, I'm into yada yada today. All right, name a diameter. Okay, so hopefully you put RA or AR. Okay, name a chord that is not a diameter. All right, so remember that AR is also a chord. Okay, but here we're looking for a W or WA. Now here's a question. Is this okay? It's a line. It's true that AW is a line. However, a chord is a segment. It's not a line. Okay, it's a line segment. So you can't have the little arrows on the end because a chord, by definition, touches both sides of the circle. So it has a definite length. It doesn't continue on forever outside of the circle. It stays on the inside of the circle. All right, now this time, watch this terminology. Now we do want to name a line that's tangent to the circle. So you could put WC, now this really is a line, goes on forever, or CW. Okay, watch those symbols. I'm meaning these things above your letters. Okay, next, hit pause. Here we go. We are given the circumference. All right, so C equals pi d. All right, and this I would like for you to memorize, but it is on your reference sheet, so you do not have to memorize this. Please don't use 2 pi r. I don't like that. It gets on my nerves. That means you're too stupid to know that the diameter is twice the size of the radius. but I know you guys are all extremely intelligent people. Anywho, the circumference is 14 pi. That means that 14 pi goes under circumference because they're the same thing. And the formula is pi d. So I need to find the radius. Well, right now, all I can do is find the diameter. To try to get the diameter by itself, we need to divide by pi. That's gone. Divide by pi. Oh, how nice. It cancels here too. Well, if pi cancels on both sides, then I'm left with 14 equals d. Well, if the diameter is 14, the radius must be 7 because it's half of the diameter. Okay, and I'm not given any units, right? No units. So no units are required. Next. Hit pause. Now we want to find the radius and diameter. So we need two things of a hula hoop with a circumference of 23 pi inches. So circumference is 23 pi. Circumference again is pi d. Alright, it tells me the circumference is 23 pi, so it needs to go for C. 23 pi equals pi d. Looks a whole lot like that other problem, doesn't it? Trying to find diameter, so I need to get rid of pi. That's pi times d. Opposite of multiply is divide. Divide by pi on both sides. So 23 is the diameter. And then to get the radius, we have to divide that by 2. And 23 divided by 2 should be about 11.5. Okay, now this time they gave me inches. So I better get over here and put 23 inches and 11.5 inches. That kind of looks like but such is life. All right, moving right along. If the radius of a circle is 17.3 centimeters, so the radius is this, we want to find the diameter and the circumference. Uh-oh, tells me round. All right, so that probably is a big old hint that I'm going to have a decimal answer. It did not ask for the exact radius or the exact diameter, so it's telling me that decimals are okay. Big hint there. All right, so if R is 17.3, next thing it says to find is diameter. How do you find diameter? Well, diameter is 2 times the radius, so if I do 17.3 times 2 in my handy-dandy calculator, I should end up with 34.6. Oop, let's get those units in there, centimeters. Okay, circumference, again, is pi d. Hadn't changed anything up on you yet. All right, C, we don't know this time, but I do know the diameter right here. So now I've got pi times the diameter, which is 34.6. You don't actually need the parentheses in your calculator, but it's a good habit to get into. So if you multiply these two things out, and it says round to the nearest hundredth. By the way, make sure you're using the pi button in the calculator. Do not use 3.14. No, no. It doesn't tell you anywhere to use 3.14, so use the pi button in your calculator. It's more precise. Okay, so C then in my calculator shows me 108.699. Okay, well, it says to the hundredth, so this one tells me what I have to do here. That 9 says this one has to go up. So basically what's happening here is that 69 becomes 70. So the circumference is approximately, still a rounded number, 108.70. Okay, and that is centimeters. Now, a lot of confusion. Students want to say this is centimeters squared or centimeters cubed, like put a little 2 here, or 3. All right, circumference is just regular numbers. It's like taking a string and wrapping it around the circle. And then after you take it, after you measure the circle, then you undo the string again and you lay it flat and you get yourself a handy-dandy little ruler and you measure it. This is not squared or cubed. Area is squared. Volume is cubed. Circumference? Nope, just a regular thing like perimeter. Okay? just centimeters. All right. This is that problem you guys don't usually like. You just have to think it to death. Pause. All right. So AR, if the diameter of circle S is 16, so the diameter over here is 16, and the diameter over here is 12. And then ST is 5. Okay? Well, in this case, the diameter is 16, so if I look at SA right here, this whole thing, this is a radius, right? So radius, if the diameter is 16, the radius must be 8. So from S to, ooh, what is that? A is 8. So from here to here is 8. Well, if from here to here is 5, then that must be 3, so that equals 8. Okay? On the other side, if the diameter is 12, that means the radius must be 6. So from T to R, it's 6. Okay? So from here to here is 6. Well, from here to here is 3. So that must also be 3, because 3 plus 3 is 6. Okay? But it wants me to find AR. See? AR? Go back and look. Well, AR is 3. What if it had asked you to find SR? It didn't, but it could. SR would be 5 plus 3, which is 8, 9, 10, 11. Okay? By the way, that's inches. You could just do IN. That's inches. Okay? If you need more of these problems, let me know. These really bother people for some reason. All right, we want to find the measure of arc AE. Now, that's a minor arc. It's the little one. AE is right here. It's not AE all the way this way. Okay? If it's named with 2 letters, it's a minor arc. These are not vertical angles, but these are. So that might come in handy. They mark this 90-degree angle for a reason. So let's see here. If that's 90, then this thing over here must also be 90. So 90 minus 38, that has to be 52 degrees right here. Okay? Well, if that's 52 degrees, these two are vertical, here and here. So this is also 52 degrees. By the way, I'm assuming that CE and AD are diameters. Because remember, on this test and in this chapter, you can assume that things that appear to be diameters are diameters. But now that still isn't what it asked me for. It's asking me for this arc right here. And remember what you had to memorize. This is a central angle. It's an angle whose vertex hits the center. So the angle, central angle, and the arc that it makes, so where this angle cuts, boom, cuts at A, cuts at E, this piece right here is also going to be 52 degrees. Okay? More central angles and arcs. Hit pause. All right, let's tackle this thing. Lots of stuff it's asking for. All right, angle TSI. That's over here. What a hideous question mark. All right, well, if this is 40 degrees, these two angles are vertical, so that must also be 40 degrees. RE is this arc over here, okay? What kind of angle is this right here? Central angle. Central angle matches the arc, so this must also be 40 degrees. And by the way, notice that's a minor arc, RE, this little one over here. Now, the measure of arc TER, 3 letters, is going to indicate that this is either a semicircle or a major arc. So let's go T through E to R. So it must be this way. So from here all the way to here. Okay? Well, I noticed that TE, this right here, that's a straight line, right? That's a diameter. That means from here to here is 180 degrees. I better change colors so that doesn't confuse everybody. This is 180 degrees, right? But I've got to go all the way to R. So this goes from T all the way around to R. So T through E to R. T through E to R. 180 plus 40 is 220 degrees. And then we have to find angle TSR. Right? Well, if all of this from here to here, if these angles all added up to 220, what would we need to complete the circle? How many degrees are in a circle? 360, right? So 360 minus 220, right? 140 degrees, which means that arc is also 140 degrees, even though it does not ask for that. All right, how we doing so far? Hope we're doing well. All right, inscribed angles, I like these. These are quick and easy. Don't overthink them. All right, this is not a central angle because it doesn't hit the center, right? This angle, the vertex, lies on the circle, and so do its edges. So this is an inscribed. I-N-S-C-R-I-B-E-D. Scribe means drawn or to draw. And then inside. It's inside the circle. So it's drawn in the circle. Anywho, if this is the case, then these two are not equal. This angle right here is half of that. So in order to get x out here, we just have to do 87 times 2. Which means that x must be 174 degrees. We like these problems. We want a bunch of these on the test. Sorry, not going to happen. There will be a few, though. So, should be a few easy ones for you. All right. Same thing. That's an inscribed angle, right? The angle is on the circle. Okay. So, that must be half of that. Half of the arc. So, 118 divided by 2. 59 degrees. Okay? You like them? Okay, well this one is a little bit wackier. Now here's what you'll notice, and if this shows up on the test, I will put this on there too. Me and yo are not diameters in this case, okay? In this one, they are not diameters, so you cannot think of them as such, okay? So there, we'll just say the center's maybe somewhere in here. That way they still cross, but they're not crossing at the center, okay? Center's like up here. Anyway, YOM, so the angle, YOM. All right, that angle is 42 degrees. The arc, the measure of arc MO, all right, so MO over here, minor arc, 2 letters, is 75 degrees. And ye is 75 degrees. I'm in Old English now. Ye students. Anywho, find the measure of angle 1. All right, if I want to find angle 1, there are several ways to do it, but let's try this. 42, you see this angle? These two, by the way, are not the same unless these were parallel. If you knew those were parallel, you could call these alternate interior angles, but they're not, okay? Doesn't tell you they're parallel, so you can't assume that. But this is an inscribed angle right here, okay? Inscribed angle. See how it cuts this arc? Just focus on this right here, okay? If I need to, let me kind of draw that out, make it darker so you can see it a little better, what I'm doing. This angle right here is the inscribed angle I'm talking about, and it cuts that arc. Okay? So remember, that's half of this. So to get this arc, you multiply that by 2, and you end up with 84 degrees over here. Now see, we've got 3 pieces of this circle. We just don't know what that is so far. So 84 plus 75 plus 75 is 234, I believe. All right, so how do I find that piece right there? How many degrees are there in a circle? 360 degrees in a circle. All right, so 360 minus 234. tells me that that angle must be 126. Or not angle, sorry, arc. Excuse me. Get rid of that. So this is 126 degrees. You may want to check me, make sure that really does add up to 360. All right, but now if you're looking at angle 1, that's also an inscribed angle. Let's see here. Ew, no way. We're not having orange and blue together. Sorry, Gator fans. That's not my thing. Yeah. Yellow friends. So this one, sorry, yellow and blue don't make green in this program. All right. So this angle cuts this arc, so it must be half of it. So 126 divided by 2 is 63 degrees. Let's go back to this. Blue, 63 degrees. Okay. On this problem, AC and CK are congruent. And the measure of minor arc SA, so over here, is 36 degrees. Okay, it wants us to find CAS. Well, that's this whole piece, CAS. They want us to find this angle. Okay, where in the world do we start with this thing? All right, a couple of things we know. This is a diameter, all right, so that cuts this into semicircles, right? Well, this is an inscribed angle, and this is an inscribed angle. Since they gave me some information about this triangle, I'm going to start over here. Well, if this is 180 degrees, this inscribed angle must be half of that. It's 90. Okay, if that's 90, and these two are congruent, that means we must have a 45-45 triangle. Excuse me. So if we've got a 45-45, that's an inscribed angle, cuts A to C, so that must be 90 degrees. Same thing here. If that's 45, it goes to K and to C, so over here is also 90 degrees. So I've got all the way around the circle except SK. So 36 plus 90 adds up to 216. And then we need to do 360 minus 216. And we should end up with 144. So over here is 144 degrees. All right, what angle does this tell me about then? See this arc? And it hits at S and K, right? And I've got to go way away to the other side of the circle. So that tells me about this piece right here, which is half of that. So let's see, SAK must be 72 degrees. Now I can add up these two. And so CAS must be 117 degrees. You might want to replay that one and look at it piece by piece, okay? All right, central angles. We like those. Okay, SGP is here, and NGI is here. What do you notice about these two? Shocker! More vertical angles! I told you in the beginning of the year you would see lots and lots and lots of these. I am not a liar. All right, anyway, if they're vertical angles, they must be equal. So x plus 18 must be equal to 3x plus 2. Subtract x from both sides. 18 equals 3x plus 2. Let's subtract 2 from both sides, so 16 equals, oh, you almost got me. That's not 3, is it? Going too fast. 3x minus x is what? 2x. You probably had that right and thought you were going to get some extra credit on your test. Close, but no cigar. Ooh, can we talk about tobacco products on a school website? Probably not. Divide by 2. 16 divided by 2. X is 8. But that's not what it asked me for. Now it wants me to find the measure of minor arc, RI. It wants to know this. Good golly. So I've got x equals 8, which doesn't tell me a whole lot of anything. So I guess I better go back up here and plug it in somewhere. This one looks easier than that one, I guess. Doesn't really matter. They're about the same with the calculator. So 8 plus 18, this must be 26 degrees. And so is that. but I need RI. So I'm going to look at this right here. What is this? Semicircle, straight line, diameter, SI. Okay, so this must be 180 degrees. So if I take 26 and add it to 68, I end up with 94 degrees, right? Now remember, semicircle. How many degrees are in a semicircle? 180. So 180 minus 94 leaves me with 86 degrees. So this must be 86 degrees here, which means so is this. Okay. Circles will get you. Find the exact circumference. All right, if we're looking for exact, make sure you hit pause if you need to. Exact circumference means we're not going to have a decimal answer. So it means that pi will be in the answer. Okay, if you see exact, and then we're talking about circumference, then pi is in the answer. Circumference is equal to pi d. Let's look over here. Well, this is the diameter of the circle, right? And that's the part we don't know, but it says that this is a right angle, which we would know it was, because if this is a diameter, then that has to be a right angle. All right, so what do we do? A squared plus b squared equals c squared. Some of you may notice that is a Pythagorean triple, which we haven't talked about a lot, but that's a specific triangle that you could memorize, and it does show up in the EOC a lot. That one and a 3, 4, 5. Anyway, you don't have to know that. You can always solve it this way. So 5 squared plus 12 squared equals c squared. It's 25 squared plus 144 equals c squared. 169 equals c squared. Pause it if I'm going too fast. So c must be 13, right? Okay, take square root both sides to get c by itself. So if that's 13, that's the diameter, that's inches. All right, if c equals pi d, and d is 13, I have c equals pi 13. Well, that just looks silly. And when you put it in your calculator, it's going to flip it around, and you have c equals 13 pi, and I better put inches in there. All right, friends, the baby is now awake, so if you hear anything random along the lines of baby noises, just disregard. She's just trying to help you out. She speaks in a language that I don't understand yet, for the most part. I understand feed me, change me, hold me, and I'm sleepy. That's about it. Anywho, let's see. If the measure of angle 1 is 3x, oh, that's 3x. The measure of angle 2 is 5x plus 34. Find measure of angle 1. Well, what do we know? Are they equal? Everybody wants to say, oh, they must be equal. It must be a 45-45 triangle. It's not drawn to scale. You don't know that. There's nothing in here that tells you that these two sides are congruent. There's nothing at all that indicates this thing is a 45-45. It might be, but you don't know that. So don't set it up equal to each other because you don't know that. But you do know that this is a diameter. If that's a diameter, this is an inscribed angle, so that must be 90 degrees because it's got to be half of this arc, okay? So if that's 90, then the three of them together add up to 180, all right? Or you could just say that 3x and 5x plus 34 must add up to 90, right? Because if this is already 90, 180 minus 90, I'll do it both ways just to make sure you get it. So 3x plus 5x plus 34 plus 90, right? This one plus this one plus this one must equal 180. It's a triangle. All triangles equal 180. Combine like terms, 8x. All right, and then that would be plus 124 equals 180. Subtract the 124. And 8x must be equal to, let's see, 56. So x is 7. And again, if you already just knew that since that's 90 and you needed to add these two up, if you understood this, you can just disregard what I'm about to do. 3x plus 5x plus 34 must equal 90, okay? Because the other two, if that one's 90, these two have to add up to 90 to get to 180. Same thing. 8x plus 34 equals 90. Subtract the 34. So 8x equals 56, and still x is 7. But that's not what it asks us to find. It wants us to find the measure of angle 1. So I have to take x equals 7, and angle 1 is 3x. So the measure of angle 1 is 3x. Well, 3 times 7, right, because x is 7. So the measure of angle 1 must be 21 degrees. All right. Now, assume that segments that appear tangent are tangent. Okay, pause it. Review tangents real quick. Go back to the first screen. What is the story about tangent lines? All right, they make a 90-degree angle with the radius. Wants me to find x, so 3 squared plus x squared must equal 5 squared. If you remember your Pythagorean triplets, this is a 3, 4, 5 triangle, and you wouldn't have to solve anything. That's 4. But if you don't remember them, which is fine, you don't have to. It just makes it faster. Okay? 3 squared is 9, 5 squared is 25. Subtract 9. X squared equals 16. And the opposite of squared is square root. Take square root of both sides. X must be 4. Okay? Not too bad there with tangents. All right, again, talking about tangent lines. So we were looking at a squared plus b squared equals c squared, because if it's tangent, that must be a 90-degree angle. But uh-oh, what is this? Okay, this is my hypotenuse. So my hypotenuse is x plus 10. That's not 10. Okay, and let's see, a. I don't know what a is, but you really do. Isn't this a radius? So is this, right? That's a radius. So that must be x as well. Okay, that is also x. Okay, so now we know what we're doing. Now we have x squared plus 20 squared equals c squared. Remember, that's c, your longest side, and always opposite the 90-degree angle. So now I have x squared plus 400, right, equals, all right, now be careful here. That means x plus 10 times x plus 10. A common mistake here is to just write x squared plus 100. That won't work, okay? So I'm going to rewrite this. You can use the FOIL method here, or you can just simply distribute. I distribute. So I'm going to take x and multiply it times both of these. X times x is x squared. X times 10 is 10x, right? Positive 10x. All right, I've used that. Now I need to do the same thing with 10. I need to multiply it by both of them. 10 times x is again 10x, and 10 times 10 is 100. Okay? Something you should notice, if we start with x squared, if you subtract x squared here, no matter where you do it, those cancel. Okay? So I'm left with 400 equals, well, let's go ahead and combine these, shall we? 10x plus 10x is 20x plus 100. Get these two together because we want to get x by itself. Minus 100 minus 100. That's gone. 300 equals 20x. And again, the battery's starting to die on the pen. Divide both sides by 20. And 300 divided by 20 should be 15. So x is 15. No units, so we're good to go with that. Okay, yay, let's try to move on to something easier. All right, we're writing an equation. All right, remember the equation of a circle is x squared plus y squared equals r squared. Okay, this is if it's centered at the origin. If it's not at the origin, it starts to look a little funny. It's x plus or minus something squared plus y plus or minus something squared, and it still equals r squared. Okay, so it's always the opposite of what you see here. So x plus 2, y minus 8. That's the easy part for most people. Most remember that. Well, they're trying to make sure you're paying attention here. Diameter is 14. but this is radius squared. If the diameter is 14, what is the radius? 7, right? Just divide by 2. Okay, but in this spot right here, it's r squared. Okay, so it's the radius squared. All right, so 7 squared is 49. So this is your equation. This is the answer it's looking for. Okay, looks like a big scary equation. If you're writing these out, your parents will think you're really, really smart. Okay, so you do circles, people think you're awesome because it's just this big, long, random, scary looking equation. All right, now we want the center and the radius of this. Well, the center, remember, is the opposite. So instead of positive 10, it's going to be negative 10. Instead of negative 2, we make it positive, right? Opposite. Radius. All right, this is in the same spot as r squared. So r squared must equal 81. They're in the same spot, right? X squared plus y squared equals r squared. Okay, if r squared is 81, opposite of squared is square root. Radius must be 9. Okay? Next. Now it wants us to actually graph these. So let's see. No crazy stuff in here, so this one must be centered at the origin. So same thing. The center, we always find the center and the radius. Center is 0, 0. And according to this, the radius must be 5, right? Because this is r squared. R squared is 25, so r must be 5. So it's centered at the origin, and then we go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, because my radius goes in all directions, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, looks like this this crooked square. That's probably how my circle's going to end up too. I'm not going to use the little circle button because you don't get to use a little, oh gross, you don't get to use a little circle button either. So most of your circles end up looking more like ovals or scary looking squishy squares. That just, I don't know, it looks like a beanbag. Okay, and then x minus 2 squared, y plus 1 squared, yada yada. Center, what is it? You should have that by now. 2, negative 1, and the radius, square root of 9 is 3. So, oh, my center is at 2, negative 1, right? Right, 2 down 1. And a radius of 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Not much better. But anywho, there are pretty little graph circles. You try doing it on an iPad. It's easier to do with a pencil. Don't judge. Alright, find the equation of circle J. Alright, same thing. Always find the center. Always find the radius. Center, let's see, 1, 2, 1, 2, 3. Center is at 2, 3. Radius, we have to count. Alright, that's supposed to land exactly, but the software is not being as cooperative as I'd like. So, looks like, let's count these because we know these. So 1, 2, 3 here and 1, 2, 3 there. Radius is 3, which gives me, let's see, x opposite, right? Minus 2 squared plus y minus 3 squared equals r squared. So that's 9, not 6, friends. Don't double it. Square it. All right, we have 2 to go. All right, Miss McGee cuts a 40-degree slice, that's a yucky degree mark, from a pie 10 inches in diameter. I'm really hungry right now. Somebody bring pie. We'll eat it. I don't do pecan pie, though. Cheesecake works. Or peach pie. I like cobblers. Sorry, I'm off task. Find the length of ON, so the length of this to the nearest hundredth. Okay, woo, careful here. Length. This is not arc measure. This is arc length. This is different than measure. This is not a degree we're looking for. This is actually a piece of the circumference. So like if we found the whole circumference, right, we would want to know just how much is this. All right, well, it's 40 degrees like right here. This angle inside here, angle A, is 40 degrees, okay? So if that's 40 degrees in there, it's 40 degrees out of how many degrees? How many degrees are in the whole pi? 360, right? Okay, so this simplifies to 1/9 of the pi, right? So I cut a slice that's 1/9 of the whole thing. Well, the whole thing would be pi d, right? The whole circumference, or the whole distance around, is pi d, because that's circumference. I'm talking about the outside edge. I'm not talking about this. I'm not trying to figure out how much is in here. All I want to know is kind of the little crust part, okay? I just want to know about the crust. All right, sorry. My husband turned off the lights whenever he brought the baby out here, so I'm operating in the dark. Okay, so I just want to know this part, the crust. All right, so it's 1/9 of the whole thing. Well, the whole thing is pi d, and the diameter it tells me is 10, so pi 10. So if you plug this in your calculator, 1/9, parentheses, pi 10 or 10 pi, it won't matter. Either way, and it tells me I can round to the nearest hundredth. So it tells me I'm going to end up with a decimal answer. This is approximately 3.49 inches. Okay. Next. Okay, what is this thing? Oh, last problem. Yay! This is a quadrilateral inscribed in a circle. Quadrilateral inscribed, drawn inside a circle. All right, and for this one, it was another memorization piece. You had to memorize that opposite angles. What is their relationship? Are they congruent? No. In a parallelogram, they are congruent. A square, a rectangle, you know, that's all of our quadrilateral rules. But we don't know that this is a parallelogram. It sure doesn't look like it. Doesn't look like a square or rectangle. We can't assume, but it doesn't look like it to me. The rule is these two things, opposites, are supplementary. So these two add up to 180. So 180 minus 128 leaves me with 52 degrees. So y is 52 degrees. And then these are also supplementary. So 180 minus 92 gives me 88 degrees. So x is 88 degrees. How could you check to make sure you're right? It's a quadrilateral, right? How many degrees are in a quadrilateral? 360. So you can do 52 plus 88 plus 92 plus 128 and see if it equals 360. If it does, you are good to go. You've answered correctly. This is an inscribed quadrilateral, and you hopefully made an A on the test. All right, thanks for watching and listening. See you in class soon.